Hi folks, we're going to take a look at another example that can be solved using the quadratic formula. Okay, so here they tell us to consider this function here, f, and they're asking us to determine the x values for which the function values are less than or equal to 5. Okay, in other words, when are the y values, the f at x's, less than or equal to 5? Okay, in order to solve this problem, I'm first going to actually try to find out when the function is equal to 5. So step 1 is to determine, okay, when is f at x equal to 5? Okay, so since I'm only interested in when f at x is equal to 5, in my equation, I'm going to replace f at x by 5. Okay, so in my equation, instead of writing f at x, I want to know when that's equal to 5. So it's like replacing my y value by 5. And I want to find the x value or x values for which y is going to be equal to 5. Okay, so let's put that in, and then plus 6. And I realize here that I've just created a quadratic equation. Okay. Now, as soon as I see the 0.5 in front of the x squared, I'm probably thinking that I'm going to be using the quadratic formula, that I'm probably not going to try to factor. Okay? But another thing that I hope you noticed right away is that it's not in the correct form. So when we want to use the quadratic formula, okay, it needs to be in the form ax squared plus bx plus c equals 0. And once we have it in this form, well, then we can find the answers by using the formula. Okay? So we'll keep that on the side as a reminder. Okay? So the first thing I have to do is bring everything to one side of the equation. It just seems a lot easier to bring the 5 over to the right-hand side. Okay? So here I'm going to take the 5 away, so I'm left with 0. So here I've got 0.5 x squared minus 2x plus 6, and then here bring this positive 5 to the other side. It's going to become a subtraction. So 0 is equal to 0.5 x squared minus 2x, and 6 minus 5 is 1. Okay, now I have it in the form that I want, so I can go ahead and use the quadratic formula. Okay, so first thing we do is we identify the a, b, and c values. So here I see that the a value is 0.5, the b value is equal to -2, and the c value is equal to +1. And now I can determine those x values. Okay, so -b, so b is -2, plus or minus square root b squared, so -2 all squared. Notice how I'm always putting what I'm inputting in brackets, minus 4 times a, which is 0.5, times c, which is 1, okay, and then all times 2 times a, over 2 times a, so 2 times 0.5. Okay, so let's simplify this here. -2 becomes +2. Plus or minus, well, let's take our calculator and calculate what's inside the bracket. Okay, so we have -2 squared minus 4 times 0.5 times 1, and that's equal to 2. Okay, and then here 2 times 0.5, well, that's just equal to 1. Okay, so I can write x is equal to 2 plus root 2. Okay, and I don't have to do the dividing by 1. Okay, or x is equal to 2 minus root 2. Okay, now even though I'd like to keep my answers in exact form here, since this is not an application question, I'm just going to approximate them just to help me solve the problem, because I still have something to figure out here. Is that I found when f at x is equal to 5, but I need to know when it's less than or equal to 5. So I think what I'm going to do is I'm going to draw a picture. I'm going to try to draw a graph, but I'm going to calculate these approximations just to help me draw my graph more easily. So I'll do 2 plus square root of 2. And that's equal to about 3.4. So this is approximately equal to 3.4. And then here, let's calculate 2 minus root 2. 2 minus square root of 2, and that's about 0.6. Okay. Now let's remember what we found. These were the x values for which the function was going to be equal to 5. That's what we originally were finding. So I'm going to draw a graph here. So here I've got 0.6, and notice I'm not going to be not necessarily going to be precise with my graph. Okay, so there's 5. So I know that at 0.6 y is equal to 5, and at 3.4 y is also equal to 5. The question is, how am I going to determine when it's less than 5? And this is when you look at the a value. Okay, that's going to help us out. When you look at the a value for this function, we see that it's 0.5. In other words, it's positive. But if we know that the a value is positive, it must mean that this is a parabola going upwards. Okay, so it means this parabola is going to look something like this. Okay, now I don't care how far down or whether it's very close. That I don't care about. The only thing I care about is when is this function f less than or equal to 5. And I see here that it's going to be less than or equal to 5 in this interval. Okay, so the way we can write this down is f at x is less than or equal to 5. Okay, now I can write it in words. Between x equals 2 minus root 2. Notice here how I'm going to use my exact numbers. Okay, and x equals 2 plus root 2. So in between these two x values, okay, and here we'll just put including the numbers because it could also be equal to 5. But I'm hoping we'll remember what we saw in Unit 1, a much nicer way of writing this out. Okay, we can say that f at x, the y values are less than or equal to 5 when, okay, and if you remember how we wrote this interval of numbers, is we could say x has to be less than or equal to 2 plus root 2, so less than the bigger one, but greater than or equal to the smaller one, 2 minus root 2. Okay, this would be the best way of writing our answer. Okay, however, if you wrote it in words, that would be fine. And even if you use the approximations, I wouldn't mind that so much. But this would definitely be the best way of writing out the solution. Okay, so just to recap, how here you were given a specific y value to work with, so you replaced y by 5. In other examples, we're often replacing y by 0. Okay, and don't forget that in order to be able to use the quadratic formula on a quadratic equation, you have to have 0 on one side of the equation. So make sure if you don't have 0, you bring everything to one side. Okay, and that's it for now.